Today we're going to do a pretty difficult repair on the mighty IBM PS2 model 95XP, one of the last and arguably the best IBM PS2. We are also going to do a rather tricky hard drive upgrade. An upgrade that might seem very simple, but on this machine it's not. Okay, let's start with a quick test. Just make sure this machine is still working. And it's slowly going through all the checkpoints. Oh no, we've got an error. We've got a 201. So this machine apparently isn't quite okay. Memory size error. Well, I haven't changed the memory, so let's run an automatic configuration. So we're gonna need a ref disk for this. An error occurred while attempting to read the disk in the default drive. Well, this machine definitely is not okay. Let's do a reboot and see what happens. No, still a 201. Oh crap, I think we have an issue that we need to fix before we do any upgrades. Okay, but now it reads the diskette, so system had an error in the battery powered configuration data. Well, I haven't touched the battery either, so something is going on here. But we still have the memory error, and we are forced to set time and date before we can continue. Okay, I'm skipping ahead here not to bore you. Automatic configuration program complete. Reboot the machine. By the way, I just had the nastiest flu, so I probably sound a bit weird in this video. And that's also why there wasn't a video last week. Okay, still incorrect RAM after the reboot. And the battery, by the way, in this machine is brand new. So let's try again. Automatic configuration is being run. Okay, automatic configuration program complete. And the machine reboots again. And we still have a RAM configuration error. It can only see 4 megs of RAM. But we've got 32 megs. So something is really messed up here. So I'm gonna press no here. And then I'm gonna go to test the machine. Remove the reference disk and insert diagnostic diskettes. Image files of these diskettes are available at Ardent. Tests are loading into memory. Well, luckily we still have 4 megs of working memory. Okay, interesting. So in here it reports 32 megs of system memory. So I'm gonna hit yes. And it will now test a whole bunch of things in the machine. So I'll skip to the RAM test. Okay, very long story short. Apparently the RAM stick in A2 is faulty. So I'm gonna have to remove B2 as well. That RAM test took a very long time. But if it found the issue with the machine, I'm not gonna complain. Okay, it is correctly reporting 24 megs of RAM, since we have removed 2 of the sticks. Now we only have a 164. That is a good sign. Okay, we've got a memory size error again. But this one was expected, because we have removed 2 RAM sticks. So I'm just gonna hit yes. And we are forced again to set time and date. And it's probably going to reboot again. Okay, automatic configuration complete. Okay, and all the errors are gone. Okay, and it boots. So, apparently we had a bad RAM stick. Now, the weird thing is that we actually swapped the RAM in the previous video when I failed overclocking this machine. But I guess it was marginal. Okay, let's do some upgrades. So, first we're going to install this Corvette card. Unfortunately, it is damaged, so we need to fix it first. Let me show you under the microscope what's wrong with this chip here. Okay, I'm gonna have to be lazy here because I'm short on time because of that stupid flu. But you should be able to clearly see what the issue is here. So these 4 pins are bent. And the PCB is quite messed up here. I can't really tell if this trace is okay. I think this one is still good. But this pin here has definitely come off the pad. Or perhaps the entire pad has come off. So let's see if we can fix it. Okay, card installed in the PCB holder, and I'm gonna go for 130. That should be sufficient. While the board heats up, let's add some flux. By the way, the card that came with this machine, I think can do about 5 megs per second. And if I'm not mistaken, this Corvette can do 40. So it should be quite a bit faster. I'm gonna be nice to this board and add some chip quick. That way we can use a lot less heat when we remove the chip. So the chip quick has a much lower melting temperature. And actually that chip just moved, so it's not going to require much heat to remove. And the board has reached 130 degrees underneath and 100 C on top of the board. I removed the nozzle from the rework station. Now let's heat up that solder. I'm gonna have to be a bit careful because we have a plastic connector here and a socket here that could easily be damaged. This is a custom IBM chip, by the way, so I have no way of checking what those damaged pins do. Yeah, that chip is moving, but let's heat some more before we lift the chip off the board, just to be sure all the pins are loose. And here's our toasty chip. I'm going to lower the temperature to 50. Now let's remove that huge blob of chip quick. I'll add some more flux and remove the remaining solder and chip quick. Being very careful not to push with the tip. These pads are absolutely tiny, so probably easy to damage. And I'm going to be extremely careful in this area where the pads are damaged. I'll have a second pass just to make sure. Now we can scoop up all the flux by twisting a Q-tip, and again being very careful in this damaged area so I don't make it worse. The trick to remove the flux as easily as possible is to use a dry Q-tip first and then just twist and scoop the sticky flux up. Yeah, even without any magnification I can already see that the damaged pad is crossed over to another pad and shorting the two. With most of the flux gone, I can turn the heat off and use some IPA to remove the stickiness on the board. Okay, that's clean enough for me. Since this is a custom chip, I am of course going to reuse it. So we need to remove the chip quick from all the chip legs with some flux and some wick. I'm gonna go slow here so I don't bend any more pins and skip ahead. Okay, let's start with the card here. So this trace here doesn't seem to be damaged at all. So the only issue with the card is this pad here. So I'm going to use my loop and a tiny knife, and then I'm gently going to try to pull this pad up and see if I can get it back into position. Problem is, that pad is absolutely tiny. Quite possibly the smallest pad I've ever tried to repair. You've got some massive magnification, of course, but for comparison, here's that knife under the same magnification. And it looks huge. Not very sharp, but it actually is. There's absolutely no way I can do this with large camera on top of the card. So unfortunately, this is going to be off camera. Well, that sort of went okay. So I did manage to push it into position. But unfortunately, the whole pad has been compressed by whatever pushed on it from this side here. So it's all wrinkly. So this may not look too bad, but again, this is on a massive magnification. I would guess there is about 0.1 millimeter between this pad here and the damaged pad. So it wouldn't take much to shorten, but once it's soldered it should be safe. But since it's a bit short, I think we need a plan B. So if we follow that trace, it's going to this via here. And I managed to find that via on the other side of the board. And I marked it from two sides. So it should be quite easy to find if we need to. And if the chip doesn't make good contact with that damaged pad, we can always add a bodge wire to this via. It would make for a much uglier repair, but I think we need a plan B for this one. And same thing with the chip here. I'm going to use the loop and a knife, and then I'm gently going to push all the pins and see if I can get them back into position. And again, there's no way I can do this with the camera on top. Wow, that was incredibly difficult. It looks far from perfect, but I think this is the best I can get for now. And once on the board, I'll see if I can do some more fine adjustments. So these chip legs are exceptionally thin. For comparison, here are my tweezers. So they're about the size of the tip of my tweezers. But let's see if we're lucky and if we can make this work. Okay, I installed the chip on the PCB and aligned it. And I'm not gonna lie, this was the most difficult chip rework I've done so far. And the only reason is because these chip legs are extremely thin and very soft, so just by touching them, they just completely bend out of shape immediately. I ended up using this needle here, and it looks absolutely huge, but it's not. It's just a regular tiny needle. So we're gonna need some luck with this one. Since the legs of this chip are so flimsy, I'm not going to drag solder this chip. Instead, I'm going to add a splash of solder to the tip, and then I'm going to solder a few pins at a time. I'm going to remove the bridges as I go by gently pulling them off the pins. Actually, I ended up drag soldering this chip anyways. So even with a chip with wonky legs like this, it seems to be the best method. Before I move on, I'm gently pushing on all the pins with a tiny screwdriver, just to make sure they're not moving. Oh, actually, this guy here is still loose. Being so wonky, they move immediately just by touching them if they're not soldered proper. So I'll add some solder to this pin here. Okay, I soldered a tiny wire to that via, just so we can get this on camera. So now we can check the connection between the chip leg and the trace. I will just quickly check for shorts in this area here, just to make sure we don't have an issue underneath the chip here. Okay, we are ready for a test. So let's get that SCSI card out. This is not a bad card either, and probably good enough for any DOS game. So let's hope this Corvette works. Okay, fingers crossed. Okay, it's slowly posting, and it's counting up the RAM. So at least we haven't messed it up completely. We've got a 165 on the display, which means found new hardware. So that's a good start. Adapter configuration error. This is perfectly normal if you replace one of the cards in the machine. The description file for the adapter in slot 1 was not found. Okay, I was sure I had a copy. Oh, I see. I guess we should insert that diskette all the way in. Remove the option diskette from the drive. Well, that was actually the ref disk. SCSI devices are being configured. Automatic configuration program complete. We're back at checkpoint 10, so the machine reboots. Awesome! So obviously that SCSI card is working. Finally, a win for this project. We had nothing but trouble when we tried to overclock this machine in the previous video. Hey, now that I think about it, I wonder if that bad RAM stick had anything to do with the trouble we had trying to overclock this machine. I think we need to find out. So let's remove the DX250 and install DX4 ODPR. If this machine is all new to you, the CPU is not installed on the motherboard in these machines. Instead, it's installed on a separate PCB. It can be removed and replaced. Okay, here goes. Fingers crossed. Checkpoint 10, 25, 40. This machine is really slow to post, so it's really nice to have this display to see that it's actually doing something. We've got a flashing cursor, it's counting up the RAM, and we've got a 169 on the display. It's reading from the ref disk. Processor card change. This is perfectly normal because we have changed it. Well, sort of. We haven't actually changed the card, but we have replaced the CPU. Automatic configuration is being run. SCSI devices are being configured. The automatic configuration program found conflicts with your adapter cards. Okay, so this is exactly the same fault we had before. An error occurred during automatic configuration and the configuration was not successfully completed. So the issue with this machine is when we install a DX4, it complains about a conflict, but when we check in the BIOS, there is no conflict. So the combination of this motherboard, this complex and CPU just doesn't seem to be compatible. Now we're back at that stupid error. So no, that overclocking problem was not caused by a bad RAM chip, unfortunately. That would have been a nice and easy fix. Okay, the next upgrade is that noisy hard drive. I don't mind mechanical hard drives, but when they are worn out, like this one, they make an incredibly annoying high-pitched noise. But upgrading the hard drive in these machines isn't quite straightforward, because this PS2 has something called IML. Let me show you on this messed up old hard drive here. Let's move the heads to track 0. Okay, so the platters in a hard drive are divided in sort of tracks like this nice illustration here. So you've got track 0 out here, and then the heads moves further in and reads the different tracks that are laid out in circles. Now here's the issue. When we make a change in the BIOS in this machine, the drive goes all the way to the end of the drive and stores the BIOS information on one of the last tracks. And this is working perfectly fine, so no issues here. But here's where we get into trouble. Finding hard drives this size in good condition is pretty much impossible nowadays. But there are plenty of slightly more modern drives like this one here. But the problem is they are much larger. So when the system has stored all the information on one of the last tracks here, the SCSI card can't reach all the way in, because it can only read 4 gig drives. And this drive here is 9 gigs, so we can basically only read up until roughly the middle of the platters. And the system never reaches those last tracks with the BIOS settings. And that gives us an IML error. But luckily there is a fix for this. To get around this problem, we need to connect the drive to another machine that has a SCSI controller. So let's bring out the massive Model 80. Okay, hard drive connected to the mighty Model 80. But this trick should work with pretty much any PC with a SCSI controller. So we have previously fixed similar issues with Seagate C-Tools version 2.23. And it doesn't just work with Seagate drives. We have also tried it with a Maxtor, Samsung and a Deskstar. So it seems to be universal software. But unfortunately it can only do IDE drives. So I went online and found an enterprise version of the software. But unfortunately they had removed this very special feature that we need to fix this drive. I removed the jumpers from the hard drive, so the ID is now set to 0 on the drive we want to change. Okay, so the first thing we need to do is to place a copy of the ASPI driver on the hard drive. Not the drive we're going to fix, of course, but this machine's C drive. I have placed a copy in my DOS folder and added this line here to config sys. So if we reboot the machine now, it's going to load that driver. Okay, and here's the magic homebrew software that will fix this issue. It's called FMT-EXE. I'll see if I can find who made the software and write it on the screen here. It's very simple software. All we need to do is to run FMT, and it will ask for SCSI ID. Since we have removed all the jumpers, the ID is set to 0. And currently this drive here has 17 million sectors. And the software is asking for the new size. And we need to get down to roughly 7,500,000 and hit enter. Continue with format. Yes. Are you really sure? Yes. Starting to format. So I'll skip ahead here. Okay, that took less than a minute. We're getting an error, but let's run the software again and check. No, that worked. So this drive now has 7,500,000 sectors and should be somewhere around 3 to 4 gigs. Okay, I reinstalled the jumpers and installed them on bit 1 and bit 2. That should set the ID to 6, and this is essential for the IBM to boot from this drive. I'm going to reuse the drive sled from the old hard drive. So we need to remove a couple of screws. And hopefully it will fit our slightly more modern drive. It's quite a bit much newer actually. Okay, let's install our nice and silent hard drive. And now we can connect the drive at the back here. So I'm not sure I will ever need SCSI 2 speeds on this machine. But if I ever do... Okay, let's boot the machine up with the reference disk in the drive. Okay, the 95 is up and running. And in here we need to bring out the hidden menu by hitting Ctrl A. Instructions, remove reference diskette. and insert the diagnostic diskette. So this is going to give us some options that are not available otherwise. Format a hard disk, and here's our new drive, and instead of 9.1 gig it's down to about 4 gigs. Let's hit OK. Format the SCSI hard disk. Are you sure you want to continue? Yes. Do you want to stop now? No. Are you sure you want to continue? Yes. This is sort of like a low-level format. I'll obviously skip ahead here. Okay, and it's done. Hard disk format complete. Okay, after reboot, we now have an error on the display that I think is an IML error, because that's what I'm expecting, since we have a brand new hard drive without any BIOS settings stored. So let's go down to backup and restore system programs, and then restore the system partition. Okay, remove the diskette from drive A and insert diagnostic diskettes. Okay, the restoration of the system partition is complete. Insert ref disk and press enter. Okay, I think we're done in here. So let's go back and boot to DOS diskettes and jump into F disk. No partitions defined in here, so let's create a primary partition and use all the available space. Okay, let's format that drive next. So DOS can only see 2 gigs here, so I'll probably add a second partition later. Okay, we're done. Let's boot this machine and see if everything works. And it boots. Awesome. Another win for the 95 XP. We're doing a lot better today than we did a couple of weeks ago. So we're now running DOS with a working IML on a hard drive that is supposedly impossible to install in this machine. Okay, the next upgrade is kind of obvious. To be a good DOS gamer, this machine needs a proper CD-ROM. And I'm gonna go with this really nice caddy drive. It's a Sony CDU561-25, made in Japan. Now this would normally be a problem, because drive rails for IBM PS2s are pretty much impossible to find nowadays. But luckily I found some files to print drive rails. However, I don't have a printer. But I have a sponsor, PCBWay.com. So if you have the same issue as me and don't have a printer, you can just order printed stuff from PCBWay.com. And as expected, these look really nice. Probably a bit nicer than what you would get from a cheap printer. I noticed, however, that there is one rail for the left side and one rail for the right side. So they are not identical. Okay, I think I installed the rails correctly. Let's give this a try. Yeah, that fits perfectly. IBM was ahead of their time, though this power supply is actually modular. So we need to add an extra cable for the CD-ROM drive. To make the installation really neat, we need to take care of these blanks. So first of all, this blank here doesn't belong here. It's designed to be used on these 2 slots only. But thanks to one of my patrons, I now have the correct cover for this bay too. It has yellowed slightly, so I will leave it in peroxide and have it ready for the next and the last installment of this project. And then we need to remove this blank here for the CD-ROM. This opening, however, is slightly larger than the drive, so we need to install one of these. Okay, I'm having some trouble installing it, so maybe we need to install it first. Well, it does fit, but there's actually a gap here. That's a bit odd. And we can't install this cover here. That's a bit strange. Not sure what to make of this. I think this is the original bezel, but it doesn't seem to fit. Well, that's a bit of a problem. So, maybe there were different versions of this bezel. Well, stuff like this is pretty much impossible to find nowadays. But I do have PCBWay, so I guess I'll just have one printed. And that too will have to be for the final video about this machine. Well, let's install it and see how this looks. Well, that cover definitely looks much better than a hacked hard drive cover. So let's put the front panel back on. Yeah, there's definitely a gap around this drive here. So I'm gonna have PCBWay print something that fits around this drive. Okay, I left all the jumpers off the CD-ROM drive. So here it is at ID 0. Awesome! Another win for the 95 XP. Well, we're not done yet. Aside from a couple of minor new issues, I also want to have another go at overclocking this machine. And then we need a sound card, of course. A proper DOS gamer obviously needs a sound blaster. If you're watching this next week, there will be a link to that video on the screen here. If you're watching this fresh, hit the bell icon below and set it to all. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up and a comment. If you're a regular viewer, consider subscribing to this channel. Thank you for watching. I'll see you next week.